So before learning how to find the equation of a tangent, learn that a tangent is a line that will touch the curve only once at a point of tangency. That means that a tangent would look something like this. It only touches the curve once at a point of that tangency. In order to find the equation of the tangent, before in lower grades we used to draw a tangent to find a gradient at a particular point. But now we find the exact gradient by finding dy by dx and then substituting the x coordinate of the given point in the answer of step. The answer which we will obtain would hence be the gradient of the tangent at this particular point. And using the gradient and we have a point, thus we will form the equation of tangent. Now, a few examples. So let's say we are given this quadratic equation and are asked to find the tangent equation at this point. So in this case, the first step is finding dy by dx, and it turns out to be 6x minus 4. Now we are given the x coordinate, so we'll simply substitute 1 in place of x, and the gradient turns out to be, how about we represent the gradient by m, and it turns out to be 2. Thus we have y is equal to mx plus c, the general form, and we know that the gradient is 2 and the 2 points given are this. So we have a point and a gradient. Thus we can find the y-intercept and hence the equation. So we'll substitute the values and the value of c turns out to be 4. And thus our equation is formed. You can also form the equation using this formula if you know this. In advanced and in area, this formula will be applied. So now, the second example, we'll start by rewriting this as 4x plus 1 to the whole power of half. dy by dx in this case is bring the power down, reduce the power by 1, and differential of the bracket is 4. So, simplifying this would give us 2 over 4x plus 1 root. Alright. Now, substitute the value of the x coordinate, and thus we will have the gradient at that particular point. So this turns out to be 9. Square root of 9 is 3, and the gradient turns out to be 2 over 3. Since we have a point and a gradient, we can find the equation. Since to find an equation we need a point and a gradient or 2 points. So we will proceed. Y is equal to mx plus c. So y is 3. This is the gradient, and the value of c turns out to be 5 over 3. And thus our final answer would be something like y is equal to 2 over 3x plus 5 over 3x. How about I take the 3 to that side, since it's a common denominator, and I'll turn out to have 3y is equal to 2x plus 5 as my final equation in a simplified form. So in order to find the equation of the tangent, Find dy by dx and substitute the x coordinate to find the exact value of the gradient at that point. So now you will end up with a gradient and uh, a point which allows you to find the equation of the tangent. Moving on, before we learn to find the equation of a normal, learn that a normal is a line that is perpendicular to the tangent. This is a tangent at the point of tangency. That is, this yellow line is the normal. This yellow dotted line is the normal because it intersects at the point of tangency. This would technically be a normal, but this is not which we would consider. So for this chapter, a normal is a line which passes through. A normal is a perpendicular line to the tangent at the point of tangency. I correct myself, to the curve at the point of tangent. My bad, pardon me. So now the steps remain similar, except for the fact we have a new step 4. That is, the answer to step 3 was the gradient of the tangent. Just remember to negative reciprocate it. That is, denominator becomes the numerator and the numerator becomes the denominator and multiply the fraction by -1 and use the gradient of normal and the point of tangency to form the equation. Let's say, for example, we have this question right here. So first of all, we start by finding dy by dx, which turns out to be 10x minus 8. Alright, we have a point on the line, so we know the x coordinate, which is 1. Substitute that, and we have the gradient as 2. This is the gradient of tangent, mind you. Thus, the gradient, I write this as gradient of perpendicular is the negative reciprocal of the gradient of tangent, which is -half. I have a point and I have a gradient, and thus I can find the equation. Again, there are two ways to form the equation. How about in this example, we cover both the ways. First of all, is the conventional method of first finding the y-intercept. So first of all, substitute the values of the coordinates and the gradient. C turns out to be -half. Now, the equation in simplified form would be something like this. We can further simplify this and write this as x plus 2y minus 1. Or we can either do this as using the formula y minus y1 is equals to m1, or we only have one gradient, so m, x minus x1, where x1 and y1 are a point, or the coordinates of a point, and m is the gradient. So this method is faster, and obviously I'd prefer this. I'd prefer that you guys use this too. And I turn out to get the same answer. Minus half x minus half. I can simplify this and I'd eventually get the same answer. So irrespective of the path I follow, I end up with the same answer, and you can follow either of the methods. Now, the second example, the last of this lecture. Find the equation of tangent and normal to the curve at this point. So start by finding dy by dx, which is 3x square minus 4x plus 7. Alright, and then substitute the x coordinate. So we have x as 1, and the gradient turns out to be 6. And this is the gradient of tangent. So how about we make a margin to save space? This, or a column. This too is a very good practice, and I do appreciate that you guys start making margins too. It just makes it easier for the examiner to understand. So equation of, copy this, paste this, normal and the tangent. So for the tangent, I have the gradient of 6 and the point 1 comma 5. For the normal, the point of tangency remains the same. However, the gradient is going to be the negative reciprocal. That's going to be minus 1 over 6. I'll use the faster formula. So I have y minus 5 is equals to 6x minus 1. And in this case too, using the faster formula, I have y minus 5 and minus 1 over 6 x minus 1. So, uh, solving the left hand side first, I have 6x minus 6 plus 5, and the equation turns out to be 6x minus 1. In this case, I have minus 1 over 6x minus, or rather plus 1 over 6 plus 5. Solving this and simplifying this further would give me something like, just a second, 6y minus 30 minus x plus 1, and I'd be left with x plus 6y is equals to 31. Finally, this is oops, this is your equation of tangent, and this is your equation of normal, and your final answer is here. So you learned how to find the equation of tangent and normal. The sequence of steps are similar. Just remember to negative reciprocate the gradient of tangent when finding the equation of normal. And so that's me, Ace the Levels, signing off. Emma,